Okay, so this problem's a little bit more complicated. We know it's weak because if you take a look, we have water here, which we can't really base anything off of in the beginning. And then the other thing we have is it's not a strong acid because it's not on the list we memorized. It's also not a strong base because it's not on that list either. Ammonia is one of those things that you might want to just kind of like remember in the back of your head that it is a weak base because it'll help make this problem a little bit easier. And it's very common to see this. Now, without knowing that, it would be difficult for us to just kind of predict that this is the base and then water's the acid in this case. So when it's not clear, you kind of have to either rely on previous knowledge. And again, this is one of those that you should kind of like in the back of your head remember that when you see it, it's probably going to be the base. And then in this case, water is going to act like an acid. All right. So again, it's not clear cut, but again, so in this chapter, some things aren't very clear. All right. So you got to remember this one is a weak base. We also know that it's weak because of the double-headed arrow here. Okay. All right. So we're in the Bronsted-Lowry definition. And if this is the base, we know that it's going to accept an H plus, right? So this is going to get that H plus. Where is it going to get it from? It's going to get it from the H2O because the H2O is going to donate an H plus, right? So if you take H2O and you subtract an H plus from it, what's that going to look like? Well, it's going to be one less H, right? So it's going to be OH. And then it's going to have a charge to balance out that plus. It's going to be minus. So all that's going to be left of that water is OH minus. Now, that H plus is going to go over here. And then instead of it being NH3, it's going to be NH4 plus. Okay? So now we have NH4 plus. We have OH minus. And after we've done this problem, now it's a bit more obvious that this was a base because look, it produced OH minus, right? So if we think back to the Arrhenius, this was an OH producer. Even though this didn't have OH in it, it in a way produced OH in there, all right? So again, these things kind of work in weird ways. This will be a weird one. I'm showing it to you because it's very, very common. So it's good for you to remember that anytime you see NH3, you think, okay, that's going to be a weak base.